This must be section. You see, all the equations that you saw so far, all of them are linear. So we're going to discuss how we're going to handle some nonlinear differential equations. These are going to be the one that you see from time to time in application problems. Okay. So there are two famous proofs we are going to discuss it, and we use the two problems from this section on the test, because there are two types of equations. Okay. You have to recognize it and solve it. Okay. But otherwise, it's not bad, but it refresh your memory. Because the way we are going to do it, the differential equation is the differential equation of the second order. Again, we are going to use a special substitution. We change it to the differential equation of the first order. When you get the first order, you have different choices. You may have a separable variable, linear equation, and from time to time, you may arrive at the Bernoulli equation. These are the only ones. You're not going to get something like exact or integrating factor. So we get a linear separable, most of the time separable equation. Okay, so we're going to describe it, and the situation is going to be two different cases. So each differential equation would have the variable x, variable y, y prime, and y double prime, because we are going to consider the second order. We are going to consider nonlinear equation of these variables that I talk about it, in which the first case is there is no y in it. Okay, the variable y is missing. And the second one, the variable x is missing. If this is going to be these two types, you can do it. Okay, and most of them are going to be of this group. So this is going to be the idea. So we are going to describe each part separately and how we are going to solve it. In both cases, we kind of use a kind of substitution method, and we change it to the differential equation of the first order. Okay, it can be solved. There is going to be a change of the notation that, it takes time a little bit in order to get to you. Otherwise, nothing to worry about. Okay, so it's a 410, and we are going to talk about, for the first time, nonlinear. Okay, nonlinear differential equation. This can be any equation, differential equations. So that's the idea. Okay. So in your book, sometimes they refer to it as a second order differential equation can be reduced into the first order equation. So I just add that title too, so that give a hint. Okay, sometimes in different books, they talk about the second order differential equation. Okay, differential equation can be reduced into equations, reduced to the first order. That give you the hint that what we are going to do. Okay, reduced to the first order differential equation. Differential equation. So that's another title if you want to look for it in different books. This is the way we're going to do it. So as we talk about it, we start with the general form of the equation, and we consider a special case. Now, what is going to be the general form? Okay, the general form of a differential equation of a second order. Of a differential equation. Differential equation of the second order of the second is the following format. This is going to be the function equation. What x, y prime, and y double. It's a general. So we're going to consider two cases: the case that the y is missing, and the case that x is missing. This is going to be the idea. You have to recognize each case and go for it. What we're going to do is in this, let's say in this section, okay, in this section, we're going to considering, okay, we consider solving, we consider a solving method, if you like. Solving solution method. For some special cases, okay, special differential, not all of them, differential equations. What's going to be special? There are two cases that we consider. Okay, so there are two possibilities. There are two possibilities. First possibility is the dependent, the variable y is missing. You know, x is independent variable and y is dependent because y depends on x. So they usually refer to the case one is y is missing. So the case one, the dependent, okay, dependent variable y, okay, y is missing. That's the case one. Y is missing. That would be the case. Missing, or if you like, y is not here, okay, in the equation. So if the y missing, we refer to it as case one from now on. So look at this chart. If y is going to be missing, so your equation should be equation of x, y prime, and y. Okay, this is the one that we're going to solve. So the equation, okay, the equation can be converted or written if you like. Written as, this is going to be the equation this time. We have x, y prime, y double prime equal to this. That's going to be the case. In this case, what we're going to do, we use substitutions. We're going to call the y prime to be u, for example. If we call y prime to be equal to the u, then y double prime will be u, right? So it would change it to what? Change it to the f of x, u prime. It would be an equation of the first order with respect to the u, we solve it, and of course we come back and then we find it. Okay, so in this case, what we're going to do, apply. Okay, we're going to apply the following substitution. Apply the following substitution. The substitution that we're going to use is, this is it. We're going to take the y prime to be equal to the u. And y double prime, see, y double prime would be derivative of u respect to the x. It's going to be du, and dx, that we call it u prime. So all the differentiation are respect to the u, respect to the x, okay? All of them will respect to the x. So apply the following substitution to change the equation to the following form. Okay, to change the equation. Change the equation into the following. So now new format would be what? Would be f of x comma u prime equal to this. So this is going to be differential equation of the first order. So y behave like, you see, u behave like y in this case, when you want to solve it. Behave like y, and x is going to be just independent. So this equation can be separable variable in u and x. It can be linear with respect to the u and x, okay? Or Bernoulli equation respect to the u and x. Okay, so to change the equation into this format, that can be solved. And that's it. Of course, when you solve this equation, you get the y. You get the u. Then you have to go back. It's going to be solved in 2 steps. As soon as you find the u, then you go back to this part. Y prime equal to the u, then you solve the second equation. So it's going to be 2 equations to solve, or the order is 2. So you arrive at 2 constants. Okay, your final answer. The general solution should have 2 constants, and sometimes some initial values will be given to you. Then you can find those constants too. So that's going to be the case. So the instruction is easy. Let's do it. Any question? So as soon as you see the y is missing, this substitution and go for it, and check to see if the result is linear, separable variable, okay, linear, separable variable, or Bernoulli equations. These are the following one. Okay, so let's see what we have for the examples. I'm going to check a couple of them for you, and you have a list in your practice test that I posted, and on that your extra one. Just you have to check it. They can be very tricky. Okay, you have to check all of these to be the result of the equation to feel confident. You're able to solve that result of the equation. Okay, so there you are. Solve each equation. Solve each equation. Okay, we go with the first one. This is it. First one. First one, we have x y double prime minus y prime equal to the 3x squared. That's the first equation. As you can see, it's not a linear equation, and the variable y is missing. So that would be case 1. Okay, so the solution, identify it for yourself that this is it. The variable y. Okay, the variable y is missing. So that's going to be the case 1. So quickly, you suppose, okay, as we talk about it, suppose u equal to the y prime. Okay, u equal to the y prime is your first, and then u prime equal to the y double prime. Go to the equation, substitute, see what's going to be the result. This is the original equation. You substitute and rewrite it. So x y double prime minus y prime equal to the 3x squared that we have. Now we rewrite it. Y double prime is u prime. So x u prime minus u equal to 3x squared. See, from now on, it's an equation in u and x. If you divide both sides by x, you will see what type of equation do you have, okay? So u prime minus 1 over x u equal to 3x squared. So equal to the divided by x, that give equal to the 3x. Okay, what type of equation is this one?
The e equals e to the
Bernoulli.
negative p of x.
No, what type? Linear.
Bernoulli.
It's going to be linear equation with respect to the u and x. So start solving.
That's p.
Remember, you have to find that integrating factor, etc. So u would be like a y that we did before. So is a linear equation. Is a linear equation. Okay, with, remember, for the linear equation, you have to identify p of x, which is negative 1 over x. You have to identify q of x, which is going to be equal to the 3x. Okay, remember, you have to get that integrating factor e to the integral of a px dx. So we are going to work with integral of a px dx. Okay, so it's going to be negative 1 over x dx. It's going to be negative ln of x. Okay, as usual, we move the negative to the top to make it to the ln of 1 over x. That's integral px dx. Then you have to bring the integrating factor. Remember, mu mu is equal to the e to the integral of px dx. So it's going to be e to the ln of 1 over x, which is going to be 1 over x. So your mu is 1 over x for the linear equation. Now remember, solution of the linear equation was y equal to the 1 over mu, okay? 1 over mu integral of the mu qx dx. But your y is u so far, because it's linear respect to the u. So u equal to the 1 over mu, okay? Integral of mu times q of x dx. Make sure you write y equal to, because it's not u equal to. Okay, substitute integrate. So this is it. This is going to be equal to the mu is 1 over x, 1 over 1 over x, integral of 1 over x times qx. Qx is 3x dx. Okay, so that gives you u equal to, that would be x, integral of x and x would cancel out. You get integral of a 3 dx. So that's going to be x times integral of 3 dx would be 3x. You are going to have your first constant here. You go with the C1 and C2. So this is going to be C1. Okay, you can multiply it. So u is going to be 3x squared plus C1x. This is u. Any question? So that's first part. As remember, u is y prime. We have to go back now to the second part. So u is y prime, because the unknown is y. So that gives you y prime equal to the 3x squared plus C1x. If any initial condition is given to you, you better apply it now. You get that C1. Sometimes it's very important to apply it. In this case, you don't have any initial condition, so we go for it. Now we're going to change the y prime into the dy dx. To find it, okay? 3x squared plus C1x. And cross multiply it. Cross multiply that gives you dy equal to the 3x squared. 3x squared plus C1x, okay, times dx. And this is like, integrated, it's a separable variable. Have the y on one side and the dx on the other side. Now we integrate respect to the x to find the y. So it's going to be integral of the dy is equal to the integral of 3x squared plus C1x, okay, dx. So that would give us the, okay, so it's going to be y equal to, integrate this one respect to the x is a 3x squared. So that gives me 3x cubed over 3 plus C1 x squared over 2. Now you operate your second constant. So the second constant would be C2. Okay, so that would be the final answer. Simplify it. So y equal to the x cubed, okay, x cubed plus 1/2 of the C1 x squared, if you like, plus C2. Even 1/2 the C1, you can call it C1 again for the constant that we have. Okay, so that would be the general solution of the equation. Again, if initial condition is given to you, they are going to give you true initial condition. So if it's given to you, you apply it. You apply one of them here. Quickly to find the C1, then you repeat it again to get the C2. You're not going to wait to do it right at the end of the course, at the end. Because sometimes if you don't apply it, you may not be able to find the integral of a second part. So this is the nature. I'm going to do one for you to see it. Okay, any question? So make sure that I'll do it, get to use the new notation that you're going to have. Okay, quickly identify what type of equation is going to be. That is the number one. Any question? Let's do one more to see the different possibilities for this type of equations. Okay, so let's see what's going to be the number 2. So checking this one. Number 2. Number two, the equation is this. It's a very popular equation. You have different form of these. Y double prime. Y double prime equal to the 2x, then y prime squared. See? Again, as you can see, the variable y is missing. Of course, it's not linear. Variable y is missing, so this is the case. The solution is going to be, again, variable, remind yourself that the variable y is missing. Y is missing. Okay, so again, you are going to let, suppose u to be equal to the y prime, okay, and u prime to be equal to the y double. Go back, substitute into your equation. So this is the given equation, y double prime equal to the 2x times y prime squared. Okay, if you substitute, so y double prime is u prime, so that gives you u prime. Okay, u prime equal to the 2x. Okay, equal to 2x, and the y prime is u. It's going to be u squared. Okay, so that would be the resulted equation. Now you have to solve it. If you change the u prime into the du dx to find out what type of equation we have. Okay, so it's going to be du dx equal to the 2x u squared. As you can see over here, you have a product of two functions, product of function of x and the function of u. So this is separable variable. Okay, so put them together. You have to put the u and the du together, and the x and the dx. You can cross multiply and then decide. So that give you 2x u squared dx. You have to get rid of u squared, so you divide by u squared. So that give you du over u squared. And on the other side, you get the 2x dx. Now this is separable variables. Okay, any question? Integrate. So we integrated, that give us a du over u squared. And that would be 2x dx. Now that you move the u up, we integrated, the other side is already easy to operate. So that give u to the negative 2 du. And this would be 2x squared over 2 plus the first constant, which is the c1. Okay, now this time, this is going to be u to the negative 1. U to the negative 1 over negative 1. Okay, we'll leave that one constant here. So that is going to be equal to x squared plus c1. Okay, x squared plus c1. You have to solve for u. So you bring it down, so that give you negative 1 over u. Negative 1 over u is going to be equal to the x squared plus c1. And multiply by negative both sides, I use the reciprocal to find the u. So in this case, your u would be what? U would be negative 1 over x squared plus c1. So that would be. Any question? Again, if you have any information, you just operate it to get the c1 over here. Otherwise, you have to continue to get the u. Okay, remember u is y prime. U is equal to the y prime. So the new situation would be get y prime equal to negative 1 over x squared plus c1. We have to solve this equation. Okay, we change the y prime to the dy dx, and we continue. So that gives me dy dx equal to negative 1 over x squared plus c1. Okay, and then multiply both sides. Okay, we want to write down as in the form of separable variable. Okay, so it's going to be negative, and this is going to be 1 over x squared plus c1 dx. That's it. Now it's a form of separable variable to integrate both sides. So that gives the integral of dy. It's equal to the can put out this negative sign, negative 1 over x squared plus c1 dx. Okay, this side is clear, it will be y. This is the integral of the other one.
The arctan.
It's going to be tan inverse. Okay, tan inverse, this is c1. You can call it c1 squared. Doesn't matter. Okay, so I'm going to rewrite it as, okay, to avoid the radical x squared plus c1 squared dx. Just remind you that if you have a dx over x squared plus a squared, so that give you 1 over a tan inverse, okay, tan inverse of x over. That's the constancy. So using this formula, so that would give us a negative 1 over c1, okay, negative 1 over c1 tan inverse, okay, tan inverse of x over c1. Okay, that's it, x over c1. Now you have a new constant, and you can call it c2, so plus c2. So that would be the final answer. So the final answer would be y equal to the 1 over c1 tan inverse, the tan inverse of x over c1 plus c2 as the final. Some people, yes.
Is there a difference between -1 over C1 and -C1? Like, do you have to say 1 over C1, because isn't it the same thing?
That would be another, yeah, you can call it another C1, yeah. Yeah, doesn't matter. We call this one C1, and then this one would be C1x. Okay, it would be fine. And some people, they continue, you see, they continue, they move the C2 to the other side, and they multiply by C1, and they use, they get rid of the tan inverse, those type of operation. You don't have to, because you already got the y. So why you want to make it complicated? Okay, y is given to it, and then you're done. So it's very unpredictable, if you like. So you have to do a couple of them to get used to them. Okay, to refresh your memory, quickly identify what type of equation is going to be. Okay, so this is you have different format of this. You will see it when we get. It seems to be all the same, but they are not. It can be done. Okay, so this is going to be the second one. So I'm going to give another one. It's getting various possibilities. So that was number 2. And number 3. We have to go number 3. Number 3 is interesting. This is another rule. You see them in that practice when they're posted. They are popular. Okay, so let's see. X, y double prime. X, y double prime equal to the y prime. That's y prime cubed. Check this one. Y double prime, y prime, and the y prime cube. Again, the variable y is missing, so that's case 1. Okay, solution. Find yourself that the variable y. Y is missing. Okay, so we have the case. Again, we are going to suppose substitution. Suppose u is equal to the y prime, okay, and u prime equal to the y prime. Go back, change the equation. This is the equation x, y double prime. Y prime plus y prime cubed. So that will be changed into. Okay, the change is that this is x, y double prime, x u prime, x u prime, and y prime is u, so it's going to be u plus, okay, u plus u cubed. U plus u cubed. Okay, that's going to be the case. Now to identify what type of equation do you have. Okay, this part is like a linear type. So if you move it to one side, so that give you x u prime. Okay, x2 prime minus u, and on the other side you have u cubed. Even you can divide by x. Divide by x going to be u prime minus 1 over x over u, okay, and 1 over x u cubed. See this one? This is linear. But to be linear, on the other side, you should have only, okay, only q of x. So what you have a power of what? Power of u. What type of equation is this one? That's a Bernoulli equation. So if you think about the y, u as y is exactly Bernoulli equation. Remember the Bernoulli equation, this part was a linear, and we did have an extra y to the end. It's behaving like the y, and you have the u cube, okay? So it's a Bernoulli equation. It's a very popular case, the Bernoulli equation. And that's it, the Bernoulli's equation. So we have to apply the Bernoulli equation method. Remember, you have to get rid of the u cube first. Divide by u cube or multiply by u to the -3. So that gives you u prime, u to the -3. Okay, minus u to the -3. This is going to be just 1 over x. We divide by u. So we resulted in u prime, u to the -3. This will be minus u to the -2 and 1 over x. Remember now you have to bring the, yeah.
Isn't there a 1 over x in the second term?
Oh, yes, thank you. 1 over x, okay, and 1 over x, okay. Now remember, we have to bring the substitution z for solving the Bernoulli type. So the z is going to be, you have to create this one as a z prime. So you take the z to be equal to the u to the -2. Okay, then differentiate it to get the z prime. Z prime would be -2, u to the -3, u prime. Then you have to solve for the u prime, u to the -3. That gives us u to the -3. U prime would be -1/2 of the z prime. We go back a substitute, then the equation would be changing to the z. So we continue with this one. So over here we have a -1/2. -1/2 of the z prime. And then you have a -1 over x of the z. 1 over x of the z, and over there you have 1 over x. And you have to change it to the linear equation with respect to the z, so we have to multiply by -2. Multiply by -2, so that gives you z prime. That gives you plus 2 over x, z, and you get the -2 over here, -2 over x. So this would be substitution z for the Bernoulli equation. Okay, any question? So go ahead and solve the Bernoulli equation. Yes.
Before like we saw this, I went ahead and tried to do it like the separation of variables. And I was wondering, why can't we do that
For which one separable variable?
for this one? Because you can still
Which
divide
one? Which
for
one?
this one.
This one?
So why couldn't you do separation of variables? Because you could still write like divide over the 1 over x and then write it as du over dx and then still switch them.
I don't think so.
No,
Put all the x variables on the dx side.
yeah. Like you can still,
It's a nice linear equation.
okay. Okay.
Especially for this, because you get involved with different notation and complex. Yeah, no, I can do it, but I don't see it.
Okay.
Okay, so you stay with this one because now you have a u, y, z. Okay, so let's go with the usual linear equation solution. Remember, this one. So you start with the p of x. P of x would be 2 over x. Okay, and your q of x would be negative 2 over x. So let's solve it. We get integral of px dx. Integral of px dx is 2 over x dx. It's going to be 2 ln x, which is going to be ln of x squared. Okay. Then we go for the integrating factor. So is going to be e to the integral of the px dx, which is going to be e to the ln of x squared, which is x squared. So the mu would be x squared. That's equation, linear equation. So this time the variable is z here. Okay, so z equal to, that will be z equal to solution of the linear equation 1 over mu integral of mu times the q of x dx. So that gives us 1 over x squared. The integral of mu is x squared, and the q of x is negative 2 over x dx. Okay. And so when we simplify the inside here, that gives us a negative 2x. There you are. Z is equal to the 1 over x squared integral of negative 2x dx. So this is going to be 1 over x squared. You're integrating, so that you have negative 2x squared over 2 plus your first constant, which is going to be your c1. Okay, these two would be simplified. So z is going to be equal to, okay, what's going to be z? Z is 1 over x squared times it by negative x squared plus c1. We'll write it as a fraction because they have to use reciprocal type. So it's like the top is like a c1 minus x squared divided by x squared. Okay, this is going to be your z. Okay, this is z. Now remember the z was what? Z was u to the negative 2. So z is equal to the u to the negative 2. Now you bring it here. So u to the negative 2 would be c1 minus x squared over x squared. That's so for u. Okay, and so change u into the 1 over u squared. So that give 1 over u squared. And this is going to be c1 minus x squared over x squared. Use the reciprocal to get the u squared, then take the square root. Okay, so what's going to be the result? It's going to be u squared. U squared is equal to, the top now is going to be x squared, the bottom one will be c1 minus x squared. And take the square root, take the positive square root. So u would be equal to what? The square root at the top, the square root of the top one, which is x. Okay, so we arrive at x over the square root of c1 minus x squared. Repeat it on the second page so they can see it. Okay, I take the square root of the top and the bottom, radical x squared. We assume everything is positive. Radical x squared would be x. Okay, and the bottom one, you have to write it down as is, which is a nice format because you have to find the y. Remember, u is y prime. Any question? So let's go. Yes.
I have mine as negative x squared minus c of 1 because I took out the negative when I was doing it.
You took out?
I think it should be fine though because it's a constant, right?
It doesn't matter.
Okay, cool.
Okay. So we go into the next page. Okay. So shift u and so there you are. So I repeat the u for myself. Here, so we have the u is x over the square root of c1 minus x squared. C1 minus x squared. Okay, c1 minus x squared this is the u, but the next step, u is y prime. Okay, so now y prime would be x over the square root of c1 minus x squared. You change the y prime into the dy dx and you continue. Okay, get used to change this one. Because yes, I know that some people they say why I have to change it. Because I can integrate this both sides and get the y right away. You better get used to it because when we get to the second method, if you don't do this step, when we get to the second method, to the left is going to be y prime. But to the right will be a function of y. In that case, you can't do this type of things. So get used to it, no harm, okay? Just change it to the differential form, then integrate. To make sure you're not going to make any mistake. Okay, that's it. So that would give us a form that we are interested in. It's going to be dy equal to the x radical c1 minus x squared dx. I cross multiplied. Now we can integrate. It's a separable variable. Okay, get a separable variable. We can integrate it. Okay. Integral to the left is easy. It's going to be y. We're going to find integral to the right. Use up, yes. You move it up because you have the x on the top. So that would be x times c1 minus x squared to the negative half dx. Okay, you can use your substitution, but if you take this one, u prime would be -2, -2x. So a -2 is missing. So we can use the short form. It's a -1/2 outside. So we put the -2 inside. It's like c1 minus x squared to the -1/2. This is going to be -2x dx. Okay, this is going to be your u now, and this is going to be your du. Okay, so it's like u to the -1/2. So y would be -1/2. Now the integral is going to be c1 minus x squared to the +1/2. And you divide it by 1/2. Then, of course, the second constant, which is c2. So these two will cancel out. The final answer. So the final answer would be -c1 minus x squared to the 1/2 plus c2. Okay, if you like, it's radical c1 minus x squared plus c2. So that gives you the final answer. Okay, any question? So that's the case with the Bernoulli. It's very popular. If you change it, you make it the Bernoulli form. Yeah. Okay. Yes.
Is there any chance that du is equal to -1/2x dx?
Du is what?
-1/2x dx? Because u would equal to
C is c1 minus x squared. So du would be -2x dx.
Okay.
Because you take the u to be c1 minus x squared. Because we find the u plus dx. The way I did it, I just create that.
Yeah.
Yes.
Are we replacing dx?
Yeah, that's my thought.
This one?
We're replacing dx with du,
Yeah, when you do your substitution, this is the way we do it, yeah.
right?
Yeah, we usually substitute to get it, but this is it. If you just put them together, you will see it right away.
I guess I was more thinking, right, you do du is equal to -2x dx,
Yeah,
and then
yeah,
solve for
Yeah, that's it, yeah.
du, and then plug it back in, right?
Yeah, if you substitute, you
Solve
get,
for dx.
yeah, if you substitute, you get u to the -1/2 du. When you substitute, you see, you get u to the -1/2 here. There you are. This is u to the -1/2 du. That's quick. Then because the number is missing, you put them together. And that quick you give it up. You don't have to go substitute for u. Get the numbers. But it doesn't matter if you want to go through this. Okay. So this is a good case. Now, we have to do one with, what would happen if the initial condition is given to you? Okay, and you must be, you must use the initial condition on that. Otherwise, it would be so complicated. Sometimes it will help you. So I'm giving you one, and because we give you one with the initial condition as well. So let's check. This will be the last one at the initial condition. Okay, and you have one in that practice one. Maybe it's the same one, I don't remember. And you have the one in your extra one, you can check it. So this is it's number 4, yes? This is the equation. Look at this equation. It's quite interesting. And the way we solve it, let's see, I don't remember. I remember when we want to solve this one, I have there's something, I think it's from your book. There's something interesting about this one. Let's see, I don't remember that. That's why I put it here, 2x y prime equal to the 0. You see, that's the equation. And we do have initial conditions. Condition is y of 0 is equal to 1, and y prime of 0 is equal to the 0. Since you have two constants, so they should give you two initial condition. Okay, let's see what is special about this one. Again, the variable y is missing, so it's satisfy our condition. Okay, so the variable y is missing. So we go with the substitution method that we have. So you're going to suppose, okay, we suppose that suppose that the u to be equal to the y prime, okay, and u prime to be equal to the y double prime. I'll go back and substitute into that equation. See what we're going to get. If you substitute, so that give you what? That give you x squared. That's okay, x squared plus 2y prime, 2u. Okay, that give you 2u, and then you get the y double prime, which is u prime. Okay, we get u prime plus 2xu. 2xu equal to the 0. This is going to be the equation they're going to have. Okay, so multiply to see what type of equation is this one. If you multiply it across, that gives you x squared u prime. Okay, this is going to be 2u u prime. Okay, 2u u prime, and you have 2xu. 2xu is equal to the, is equal to the 0. So this is going to be the type of the equation that you are going to have. Any suggestion? How to solve this one? What's that?
Reduction of powers.
Reduction of powers.
Whatever 4 points.
Cauchy-Euler stuff.
Exactly what we have to do. Well, just look at the format that you're going to have for this one.
No, it's the one with
Using what?
It's the one.
Right? What do you mean?
Wait, I think I remember. Let me see.
Variation of frame.
Yeah,
Nothing to do with the relation.
which one is it?
Replace it with R?
No, you see, look at these terms that you have. Terms, see? So look at this. It's not those ordinary one that you'll be able to take care of it because the difficulty is, you see, you have the u prime and the u prime here. So, and the u is here again. So it's not going to be the type that you can pull out the u prime and try to do the linear one because it's a 2xu that you have, okay? You have 2xu that you have, but just think about the separable variable, but a nice one. For the separable variable, look at these two.
It's the derivative of the other.
The derivative of what? These two
2xu.
together is derivative of what? You? No, just you can't think about it.
It's, oh,
Since it's a two terms, it must be a product of two functions. Derivative of the first times second, second first.
product rule.
Product rule. Of what? That's the question. Look at these two functions. Give us a product of two functions with derivative like this.
X squared u.
X square u. If you get x square u, you say if you get x square u, put this together. So we put this together. These two together, and the other one, this is going to be 2u, right? Okay. Now, if you group them together here, so this is what? This is x squared u prime, if you like. Because the derivative of the first one will be 2xu, plus the derivative of the second times first. That's the one, okay? This is of course equal to 0. If you move the other one to the other side, what is this? The function of derivative is 2u prime. U squared. So that gives x squared u prime, and that gives you u squared prime.
Where would the two go?
Prime.
Oh, yeah.
Okay. Now you see you have a kind of three ways theorem we got it. You have two functions with the same derivative. You know that. You integrate it. So the result will be what? So integrating both sides. You know that the functions are going to be the same, but there is a constant in between. So you are going to get the x squared u equal to negative u squared plus a constant c1. Okay, so it's very, very special. I think it's really in your book. I remember, or in some books, on one book. So this is it's very, very special now. So we have it. So what we can do is we can substitute for u the second part. Okay, you can substitute for u and start working for the y prime. Okay, so this is going to be the case. So it's very special, but that gives you an idea that they are nonlinear. So you may get different method to do it. Yes.
Wait, how come only the right side when you integrate gets a constant? Why not the left side?
There is going to be one constant.
They both get a constant, you just combining them.
It's because anytime you integrate, you get one constant. Okay, it doesn't matter to the left or to the right. Okay, so change it to the y prime. Okay, so u is equal to the y prime. So it's going to be what? It's going to be x squared y prime, and this is going to be negative y prime squared. Y prime squared plus c1. See, this is the equation that you have to work on it. Now you better apply your first initial condition now to make it easier to handle it. Okay. So the initial condition, we bring it in. You see, the initial condition is what? The initial condition is y prime of y prime of 0 is equal to the 0. There is no y. So we just apply this initial condition. If you apply it, what's going to be the result? So x is 0. You see, x is 0. So that gives 0 here. Okay, it's going to be 0. And this is going to be 0 because the y prime of 0 is 0. So that gives you 0 plus c1. So that will give you that the c1 is 0. It's very helpful. C1 is going to be 0, then we can continue solving that equation. Otherwise, it would be not possible. Okay. So, so far your equation, the result is going to be x squared y prime. What is going to be equal to the negative y prime squared. Okay. So that's an easy equation to solve. So what we can do it, you have the y prime and the y prime squared. You can assume that the y prime is not equal to the 0. Because if y prime is equal to the 0, y would be a constant. So that would be a trivial solution. So from now on, you assume that the y prime is not equal to the 0, then you can divide by y prime. Okay, so I just show you that I did divide it. So that give you y prime, and this is going to be negative y prime squared divided by y prime. So in that case, you simplify the y prime, so that give you x squared equal to the negative y prime, which is very easy to solve now. Okay, now switch the y prime to the d by dx, and do the job. So this is going to be y prime equal to the negative x squared. Dx is equal to the negative x squared. Okay, cross multiply, dy is negative x squared dx. Integrated, dy integral of negative x squared dx. So that gives y equal to negative x cubed over 3 plus c2, your second constant. Okay, but you do have initial condition. The initial condition is what? Initial condition that y of 0 is equal to 1. So that tells you that 1 equal to the, replace the x by 0, is equal to the 0 plus c2. So c2 would be 1. So the final answer is y equal to the negative x cubed over 3 plus 1. That gives you the final answer. That give an idea that, you know, if you get this type of function, this is another idea that you may search to get this truth. Okay, so that's case 1. You break and we take the case 2. Case 2 is going to be a little bit different than substitution. But it can be
Activity.
already.
I'm sure that.
And if that's both ways, then we get a finish.
Do you have the quizzes? I wasn't able to get mine last week.
Quizzes. Wow. You mean quiz 2?
Yes.
No, I'll check to see if it's in.
Okay, yeah.
Okay, okay, to check this is again.
Miss this train and then my parents are like, so I get B for missing the train and then we take my car. The hotel. Like, really that.
Yes.
And did you post the answer key? Did you post the answer key for this quiz?
No, there is an answer key. It's part of the recording and I delete that.
Yeah.
Problem. Didn't want people to see it. But this is the answers.
They like a magnet. Look, I think you got the class. In this class, in this program. I'll look at the QR codes. Wait, oh, is that only the option like new integer?
Professor, I couldn't find the lecture that was posted on the 4th.
Yeah, I check it.
I saw the 6th and I saw the 28th.
I think that was you see that the lecture in the previous session was not done, the recording are posted.
28th.
Yeah, it should be. That should be the reason.
Wait, let me see in my notes. Did you do 13.2 on the 4th?
Alright.
Because I don't know if I even got 13.2.
Then what you join us to do? Yeah.
No, I didn't get time to check it, but I know that may be the reason. because the topics are there.
Like, this is
What was
all,
the topic?
you didn't get into continuity on the video. You did on Wednesday for the practice exam, but I don't remember like there being a lesson on continuity.
I'll check it.
Okay.
Yeah, because I saw that I missed 1 week. I mean, when I say week 1, 2, 3, 4, 5, 6, I compared it with this class.
Yeah, I could show that. Like you just posted 11, right?
Because once that, you know, the recording I posted was much more than what I covered in the previous lecture. Maybe that's the reason. I'll check it. Good time.
Yeah.
Did you finish your quiz?
Yeah, I don't know if I did that good on this one.
Did you do the last problem? 5?
I have my quiz right here, but I remember I had a lot of trouble with it.
The 5th one was a little bit tricky.
For the yeah, there's definitely gonna be the one I dropped. It's determined, and I didn't even have access to the lessons, so I didn't even know what I was supposed to do. So I just said it was continuous though.
It's continuous, but your professor.
Yeah, I
This
didn't.
is very tricky
Yeah.
because you don't have those, remember those bonded
Mhm.
factors.
Yeah.
That we talk about it. So they do it is interesting because so you have to estimate it
Mhm.
to make it 0. So when you did it, you estimate by x cubed.
Yeah.
It's not. So you get the x here, you put absolute value around it, that you absolute value of x, absolute value of y, absolute value of z and stuff. So instead of absolute value of x, you consider for x squared.
The mouse pad's much.
Radical y squared, radical z squared. Now the radical x squared is less than radical x squared plus y squared plus z squared.
Yeah, that makes sense.
Radical y squared is radical x squared. That is all of them are known.
So would it
So
be
on the
someone?
top we get the bottom. The bottom is the norm to the third power. Down the bottom you get the bottom one. So we cancel it out. That give a norm of the x squared plus y squared plus z squared squared. So it's not x cubed. It's going to be the norm, the difference between those.
And then is that using squeeze theorem?
Yeah.
Yeah.
And it's very nice. Part. I just want to say.
And then for 4, I don't know if was it 1/2 for 4B?
Yeah.
Oh,
Yeah.
so I did this right?
Yeah.
Oh, shoot, okay. I had no idea if I did that right.
That 5th one is very, very special. I just want to see this type of proof.
Did you go over that in lecture, like the norm and
Which one?
stuff? Like have it to do like I know you did a little bit on the 28th.
Not directly, but this is something that you learn through the experience. It's a very unique problem.
Yeah, because I couldn't find any on the textbook that
No.
had a 3 variable, checking it was continuous.
Oh, because I used to teach to the math major, so
Yeah.
that's nice. I propose the solution, then you can check it for the test.
But if I got 4B right, then I think I did fine, because you dropped
Yeah.
one, right?
Yeah,
Okay.
that was the plan, not to be able to use, you use a little bit the 5th one.
Yeah.
Because that's crazy, wanted to see it. I'll check that one, and if it was missing, I post it. Not going to be. I check it by.
Because also like on the videos, I watched that whole video and you never like wrote like, okay, this is lesson 13.2. So I think like was 13.1 really long?
Because we do all of them together. I know, I remember that was from a summer. It was a long
I see.
session.
Yeah. Okay.
I'll check it, let you know. Okay. Yeah.
I don't know if we have enough time, but I just had a quick question. Could you remind me how you get this, raised Dawkins coefficient?
Find the derivative. See the second derivative, first, and the next. Okay, drop it in. Everything will cancel out. Sine by e to the negative x.
Right.
Okay, two numbers.
Yeah.
Because something like, 5a1 minus 3a1.
Right. Yeah. True,
So you have to differentiate.
yeah, I did
Probably you missed the,
probably a sign.
yeah, I was surprised. You see, I put the question mark.
Yeah,
Because you shouldn't get this type of thing,
right.
That's okay.
because you know that you must get a constant.
Maybe in a.
You must do something on
Yeah.
yes, this is
I might see that bit.
second derivative. You can see twice here. One.
We study when you can do anything.
Is it x or x
I
squared?
really
X,
only have I only have one.
It's here somewhere.
Yeah.
It's because you
You
go.
say you shouldn't get, when you substitute
So I gotta,
all
like,
these
wait.
x e to the x, e to the x, must
Semester.
cancel out.
Right.
If it doesn't cancel out, probably mistake.
Yeah.
It's a sign of it.
Yeah, that's what I thought was funny, is that I know this is wrong, but I realized I just figured out I need something.
This is not correct.
Right.
Probably one of these signs.
I didn't wake up when I could get up.
Yeah.
One of them has been equal.
Yeah.
They must cancel out.
Right.
My sleep schedule.
Yeah, I just
revolved
read like that, 'cause I ran out of time for one something. But,
No, that's what he
I
does
mean,
now.
most likely
But
the same
last
thing was
semester he
probably
wasn't that
easier.
busy.
Yeah, just check it, make sure what is.
Yeah.
right.
Just kind of.
Yeah. Would you mind if I took a picture?
And then the only other person is like.
Thank you.
He's like in a flat. And he still has time to put.
Okay, let's check the second type, type two. Type two, it's a little bit technical because you don't have the variable x. You don't have the variable x, then you want to integrate, you'll be in trouble. Okay?
It's not like there's.
So let's check. We're going to have a nonlinear equation in which the variable x is missing, okay? So this is type two. Okay? So in type two, the condition is the equation. Okay, the equation is not contain the variable x. The variable x, or we say the variable x is missing. So this is the one called case two. So our equation will be in this form. You get the y prime by double prime. Okay. So in this case, we have the following equation. The equation of the following case can be written into this. So you have f of y prime, y double. So this is the case. Now the difficulty is all of them, you see, when you say y prime, y double prime, they are a function of x or differential respect to the x. We do the same substitution, we do the u equal to the y prime, okay? But you cannot do if you do u equal to the y prime and the u prime, so then you are going to have u and the u prime and the y. But derivative is respect to the x. So you can't do it. So what we have to do is, we do a little bit of a chain rule type substitution. Look at this one. We need to apply the following, okay? Apply the following. apply the following substitution. So it's going to be substitution. The same thing that you did. You see y prime would be u. That's it. Then y double prime is u prime. And what is u prime? U prime is what? U prime is the derivative of u respect to the x. Since you have the y and the y double prime, you should have derivative respect to the y to be able to solve this equation. The x is missing. So what we do is we use the chain rule here. Remember du dx, you can change it to the what? You can change it into the, okay, you change this one as du for the y double prime would be u prime, it's going to be du dx. I change it into the chain rule du dy, okay, and dy dx. It's the same thing, use chain rule here. This is kind of, dx and dy would cancel out, you arrive at the du dx. And what is the advantage of this? The advantage of this is going to be this dy dx is what? Dy dx is y prime. And the y prime is u. Okay? So this is going to be y prime. So this is going to be du dy y prime. And the y prime is u. So this is going to be equal to the, this is going to be equal to the u du dy. So the substitution that you have to use are going to be the following. You take the y prime to be equal to the u. Okay, y prime equal to the u. That y double prime be equal to the u du dy. See, now that makes sense. If you substitute, you see, to change your equation into the following. So look at this one. To change the equation. The equation, original one, into this one. It's going to be something we can call it g, the function equation. So this equation would have a variable y, variable u, and the differential of the u du dy. Look at this. Now it makes sense to be able to solve it. Okay, so your u prime, if you like, okay, is going to be just taking the derivative with respect to the y. With respect to the y, the variable is y, and this is it. Like y, u, and the u prime. Then you have to keep this notation as du dy. Continue, you will find the u, and you come back and do the. Okay, so it's going to be a technical point to get, because you don't have the x, so you cannot save the y prime and the y double prime. Okay, just make sure you use the proper substitution. Any question? Let's do it. See, operate in action. So that's it, the equation. You want to solve each equation. So each equation. First one. First one is this one. Y double prime. That's 2y. Y prime cubed equal to this. As you can see, there is no x in it. So it's a type 2. Okay, so variable x is missing, solution. The value. Okay, the variable x is missing. So that would be type 2. So we're going to suppose, okay, you're going to suppose that the y prime is equal to the u, and y double prime is equal to the u du dy. That one is differential form. Back switch the equation into this form. So our equation is, I repeat it, y double prime 2y y prime cubed equal to the 0. Substitute, your y double prime would be u du dy. That's a y double prime. That's 2y y prime. Y prime is u. I give you u cubed. U cubed equal to the 0. So this is the equation that you have to solve. Remember, from now on, you have your function is u, the variable is y, and your derivative is du dy. Okay, to be able to do it. So you can assume that the u is not equal to the 0, divide by u. Okay, u not equal to the 0 because u is u prime. In that case, the function will be constant function. So divide by u. Divide by u, your equation will be changed into the du dy, okay, plus 2y u squared. Squared equal to the 0. So the function in question, or the function of y and the function of u, you have the product of a 2y times u squared, so we can change it quickly to the separable variable. It's going to be separable variable, it's going to be u and du, y and dy. And then you'll be able to do it. Okay, most of the time it's going to be separable form. Any question? So I go to the next page to do it. Okay, I move this one to the other side and put the u and the du together and the y and dy. Okay, so this is going to be the next step. So move one of them to the other side. So that was, this is what we have. It's a u du dy. Now is equal to the negative 2y. Okay, I'm sorry. This is, oh yeah, I divided already. So du dy. Okay, du dy is equal to the negative 2y u squared. Okay, that's it. Cross multiply and put them together so that the du negative 2y u squared dy. So you have the u here, so bring the u squared. So that give it du over u squared. And on the other side, you get the 2y dy. So now you get the, okay, separable variable. Integrate. And move u to the negative 2 at the same time. So that give you u to the negative 2 du. And this is going to be integral of a 2y dy. Okay, so that give it u to the negative 1 over negative 1. And that give you 2y squared over 2. You can put the c1 here. Okay, simplify it. Bring the u down. So that give you negative 1 over u. And this is going to be negative y squared. That's c1. Then multiply by a negative sign. And then switch it. Okay, it's going to be 1 over u equal to the y squared minus c1. And if you use the reciprocal, it's going to be 1 over y squared minus c1. Okay, so this is going to be the case. So that's u. Yes.
At this point, we shouldn't try to solve for that one.
For what? For
Slash squared, like we couldn't try to see 1 over.
no. Just bring. Now you have to substitute u first to see what the situation is. Yes.
Does it matter if it's positive or negative? C1.
It doesn't matter, but just keep it as is. If you change it, or if you need it, you change it. No. It's a C1. Okay. So it's substitute for u to see what type of result is going to be. Remember, the u is going to be, okay, go back. U is a y prime. Okay, y prime, which is at the same time, you know, that it's a dy dx. Or can do it in 2 steps. So it's going to be y prime. Okay, now we switch it into the dy dx and we work on that equation. Okay, so this is going to be the case. Now cross multiply, this is what I talk about it. And I'll take the integral directly. You have to cross multiply. So we cross multiply it, that give you y squared minus c1 dy. And then we get the dx here. Now that's separable variable. Integrate y square minus c1 dy. This is integral of a dx. With respect to the y, so that give a y cubed over 3 minus c1y equal to the x. You can add the c2, you know, I added to the other part. You can add it to the first part, it doesn't matter. Okay, if you like, you can multiply both sides by 3. So that give you y cubed. Okay, you can call this on c1, doesn't matter. Okay, minus c1y, and this is going to be 3x plus c2. So that would be the final answer. Okay, so we got to be careful. I've seen some people, they make a mistake here. They didn't change it to the, okay, when they y prime, don't rush. Just to change it to the dy dx and just take that integral. And that's switching the notation sometimes, okay, need more attention to be able to do it. Okay, so this is one. Any question? Given initial condition, again, for this part would be very useful for this group. So I'm going to give one. The initial condition, okay. So one with the initial condition. Okay, let's get this number 2 with the initial condition. Okay. That's it. The equation is y double prime. Okay, equal to the y squared y prime as y prime squared. So that's a y and y prime. And we have initial condition of y of 0 is equal to the negative half. And the y prime of 0 is equal to 1. That's the case. When you check the equation, there is no x in it, so it's a type 2. Okay, solution. Note that the variable x, okay, the variable x is missing. Variable x is missing, so your substitution will be of the type 2. So we're going to suppose, okay, you suppose that the y prime is equal to u, and y double prime is equal to the u dy. This is the substitution. So bring the equation and substitute. So this is the equation, y double prime, y squared, y prime, it's y prime squared, substitute. So if you substitute over here, it's going to be y double prime. So this is going to be y, u, du, dy. That's a term to the left. To the right, we have y squared, which is a y squared, times y prime, which is u. Okay, plus y prime squared, which is going to be u squared. See, that would be the result of the equation. You can divide by u quickly to simplify it. Okay, we assume that the u is not equal to the 0. And we divide, so that gives us y du dy, okay, equal to y squared plus u. This is going to be the case. Okay, remember your equation is going to be equation in u and y. So this is something like the u prime, if you like, something like the u prime, and this is something like the u. So if you put them together, you have y is not separable variable, of course, because this is sum. So they are going to be the product. In that case, it's going to be separable variable. So if you put them together, you get a chance of something familiar. That's it. You can divide by y. So that gives you du dy minus 1 over y, u equal to the 1. What type of equation is this one? It's a linear. It's a linear with respect to the u and y. You want to write the formula, you can be careful, okay? So is a linear equation, is a linear equation. Okay, linear equation in terms of, okay, in terms of u and y. So you go with the py because your variable is y. So solving it, it's going to be, we start with the p of y, which is a negative 1 over y, over q of y. Y. So you have to find that integrating factor first, mu. Okay, we go with the integral of the py dy. It's a negative 1 over y and dy. It's a negative ln y, and it's ln of 1 over. No constant c so far. So we get the mu. Mu is e to the integral of py dy. It's going to be e to the ln of 1 over y, which is 1 over y. So that would be your mu. Okay, now solution of this linear equation, but remember your linear equation is u in terms of the y. So the solution would be u equal to 1 over mu integral of mu times q of y dy. So your variables are consistent with the format that we have. Would be easy integral to find. So it's going to be 1 over mu. Mu is 1 over y. Integral of 1 over y. Q of y is y dy. Okay, this would cancel out, and this is going to be just y. So u equal to the y integral of the dy. So it's going to be y times y plus c1. Okay, so if you multiply together, u would be y squared. Y squared plus c1y. So this would be your u. Any question? U is y prime. You substitute continue, and substitute you have the initial condition. You're going to apply your initial condition now and then continue. Easier for us, okay? So we go with the fact that the y is y prime. So that give you y prime equal to the y squared plus c1y. Okay. Now initial condition. You see initial condition is replacing x by 0, y by negative half, and the y prime by 1. This is your initial condition. Initial condition gives you at 0. So x is 0. So if you substitute this number, so that give you 1. Okay, that gives you 1. Y squared would be negative 1/2 squared. And this is going to be plus c1. Okay, c1 times y, which is a negative half. So we try to find the c1 here. Okay. So negative half square would be a quarter. Okay. So that gives us what's that? It's going to be 1 equal to a quarter and minus 1/2 of the c1. Okay, you move a quarter to the side, that give it 3/4. Okay, it's going to be 3/4, and then you multiply by 2. Eventually, I think c1 would be negative 3/2. I mean, you can do it, like, it's going to be 3/4 equal to the negative 1/2 over c2, and then you simplify it. That will give you 3/2. So that would be your c1. You go back, substitute, and you continue. Not done. You have to find the y.
So isn't it negative 3/2?
Equal to. You are right. Because 1 is, but yeah, thank you. Negative 3/2. Very good. Okay, so let's continue and get officially what the y prime is and then work on it. Any question? So what's going to be y prime so far? So, and this is it. So y prime would be, remember y prime was y squared and the c1y. So y prime would be y squared minus 3/2 y. So this is what we get so far. We have to continue to find the y. Okay, replace y prime by dy dx and continue. That give you dy dx, okay? Dy dx, which is going to be equal to the y squared minus 3/2 of y. So switch. Y. This is one of the problem in your book. Negative 3/2 y times dx. Okay, that's it. So you have to put the y's together, so that give you dy over y squared minus 3/2 of y. Okay, and the other side will be dx. Now we get the separable variable now. So if you integrate it, that give you dy over y squared minus 3/2 of y. And the other side we get the dx. Okay, that integral is easy. The other side, so that give you dy over y squared minus 3/2 of y, equal to the x plus c2. And you have to find this integral. Okay, how can we find it?
Inverse secant.
No. Y squared minus 3/2 y is factorable. Okay, you need partial fractions. Okay, so you know it can be done easily. So partial fraction, I do the partial fraction first. Okay, so that's y squared minus 3/2 of y. You know, you factor out the y, that gives you y minus 3/2. So you have two fractions. Okay, this is it. One of them y. The other one is y minus 3/2. What's going on the top? You see, this is one only. So what you can do is you can put the one and negative one on the top, and then decide if it is going to be correct. Because the y should disappear. If you do this one, you see, if you multiply it, if you find the common denominator, the top would be what? Would be y minus 3/2 minus y. So these two will cancel out. You get negative 3/2, and you want 1 here. So you have to switch this. You have to divide both sides by the negative 3/2. Okay, if you divide this one by negative 3/2, that gives you the result. Okay, so this is it. Is going to be, okay. So if you divide by negative 3/2, it's like multiplying by negative 2. That's a shortcut that you can apply. Okay, this is it. So that gives y minus 3/2. Okay. Yes.
Oh, why is it a -1 on the partial fraction?
This is the way you can do it quickly as a shortcut, because you don't need any y here. So when you find the common denominator, the y should disappear because there is no y here. So if you want the shortcut, you put the -1 here quickly, because in that case, the y would disappear.
So it just
But
works.
then, yeah, when it disappeared, you get negative 3/2. But you want the 1 here. So what you have to do is, you have to divide these 1 that you did by negative 3/2. So this must be 1 over negative 3/2, and this must be 1 over negative. You know, it's a kind of operation that we do when we do the partial fractions.
Okay.
You don't believe it, you just call it A and the B, you know, just cross multiply together. It's the numbers. Okay, so this is going to be the case. Now we can integrate it. To find the integral, so the integral of y squared minus 3/2 y, would be what? Would be negative 2/3. Integral of 1 over y dy. That's 2/3. integral of 1 over y minus 3 half. So eventually negative 2/3 ln of y, that's 2/3. Okay, ln of y minus 3 half. This is going to be that integral. Just put it over there. So the final answer would be of this format. The final answer is negative 2/3 ln of y, that's 2/3 ln of y minus 3 half is equal to the x plus c2. So that give you, I just wanted to see, it's a nonlinear equation, so you should expect something different. You've got to be patient to be able to know, get this true. Yes, what's question?
Do we have to solve for C2?
Oh, yeah, we have to find the C2. So we need a calculator maybe. So what we have, what is the initial conditions? See if I got it. No, I don't. So what is going to be the initial condition that we did have? Initial condition is x is equal to the 0. X equal to the 0, y is equal to the negative half, and there is no y prime over here, okay? So you just substitute to get these numbers. With the negative 2/3. You have to use the absolute value for these y's, of course. When we do the, if we need the ln function and you need it here, because you want to put the negative 1/2. So that give ln of 1/2. This is going to be 2/3 ln of inside is going to be absolute value of negative 1/2 minus 3/2. On the other side, we get 0 plus c2. So this is going to be negative 2/3 ln of 1/2. Okay, that's going to be plus 2/3. Negative half, negative 3/2 would be negative 4 over 2, it's ln 2. Okay, so that will be ln 2. ln 2 equal to the c2. In fact, they're going to be simplified. Ln of 1/2 is negative ln 2. So that give you 2/3 ln 2 plus 2/3 ln 2 equal to the c2. Okay. So, if you put them together, that give you 4/3. So c2 would be 4/3 ln 2. So you have the other constant at the same time. Put them there to put it together. Okay, so that gives you a kind of operation that you have. This is always the case. The second one, yes.
Did you say that you turned that natural log 1/2 into natural log 2 because of the negative in front of it? You just turned it into an exponent?
That's it, yeah. It's going to be, it's going to be ln of 2 to the negative 1, yeah. There's going to be ln of 2 to the negative 1, which is negative ln 2. Negative ln 2, and you put them together, and you get a final answer. So, yes.
C2 would just be 4/3 ln
That's
2?
it, yeah. I didn't find it here. Put them together and get the final answer. Okay, we are ready for test. That's it. So we practice on Thursday. I put that practice test for you. We'll have a look at it. There are some tricky problem on the. You see, the test would cover these methods that we talk about. These numbers. Your job is variation of parameter. I put the best possible one on that practice one, all the possibilities. And I try to do most of them. Otherwise, I put solution.
Did you say the practice day is Tuesday? Or is test day Tuesday?
Test day is when you come back from your.
Tuesday.
No, I do the.
Oh, on Thursday. I forgot it's Tuesday.
We'll be
today.
done with chapter 4. The test would be on chapter 4.
Test will be on all of chapter 4?
I wrote it
Dude, it was crazy.